All right, guys, I know some of you don't prefer me to use the camera here, but I think for graphing on this, it'll be a little bit better. So 342, we're talking about exponential functions. And we're also going to talk about something called asymptotes. Some of y'all had some questions about that before. This is where I'm going to really go over it a little bit better. So in an exponential function, the graph is a smooth line with a rounded curve. All exponential functions have an asymptote. They also all have a y-intercept. They're all across the y-axis. They may or may not have an x-axis intercept, an x-intercept, but they have at most one. So in other words, they may cross the x-axis or they may not. But if they do, they will cross at most one time. Okay, they will not cross twice. All right, so let's look at some key features here. All right, so here we go. Key concepts. Pause the video, read these on your own, take your notes from them. I'll do examples with it in just a second. The one I really want you to pay attention to is the last one, and that's why I just slid down so you can see it. The end behavior or the behavior of the graph as x becomes larger or smaller will always be one of three descriptions: infinity, negative infinity, or the asymptote. We'll do some examples of that as well. All right, so let's get on to example one. All right, so it says example one here, create a table of values for the exponential function given here. So that is f of x is 3 times 2 to the x power plus 4. Okay, and I want to create a table of values, so I want my xy chart or my f of x chart. Okay, and then I'm also going to need to graph that. All right, so we need to keep that in mind as we're moving forward with this. So the first thing I want to do is figure out my table of values. Now, you can plug in points individually, or this is where you can use your calculator to really speed up this process. So in the calculator, okay, we want to hit table, this table key right here. Okay, it says to enter a function. Well, we know what our function is. Remember, f of x is just y, so we're okay there. So 3 parentheses 2 close parentheses exponent. This button down here, right here, will give you a variable. Okay, and it will give you the variable x. And then get out of the exponent by pressing right on your little arrow buttons. And then I need to add 4. Okay, once you've done that, hit enter. So I'm down here at enter. And it's going to bring up a little window. Now the question is, where do you want to start counting? It really doesn't matter because you can use your arrow key to go up or down as needed. I'm going to start at, say -6. I want to see on both sides of the x-axis here, on the y-axis. So I'm also going to make sure I'm counting by whole numbers. So step at 1 and let it just autofill your chart. All right, we end up with this. That's ugly. I don't want that. I want to know a decimal approximation of that. So down here, right, little double arrow key, if you'll hover over that and click it, it'll spit out that that's 4.04. All right, so let's pick some to write down. So I'm going to do -4, and this is just the ones I'm choosing so that I can get an idea. -4, -2, 0, 2, and 4. All right, so -4 is 4.1875. All right, -2 is 4.75. 0 is 7. 2 is 16. And 4 is 52. Okay, if we know something about a curve, we kind of get the idea of what's happening here. But let's go ahead and graph those and see what we got. So I'm just going to create me a little graph here. And again, this is just a rough sketch. Okay, you can make yours as nice and neat, as pretty as you want to. You can use graph paper, feel free. All right, so here's what I'm going to do. I'm going to count by fives. All right, and then on this direction, I'm going to count by 2. So 2, 4, 6, 8. All right, so at -4, I was just a little bit under the 5. Okay, and then at -2, I was still basically in the same place, but I'm a little bit closer to the 5. And like you said, it's going to be extremely hard to see. Then at 0, I'm at 7, so that's roughly here. At 2, I'm at 16. And then at 4, I am at 52, which is way up here somewhere. And you can just kind of estimate it like I'm doing. If you're just sketching. Now, if you're using a grid paper and you want to show the whole thing, feel free. Okay. All right. So the asymptote is this little, and I'm gonna draw a little dotted line here to show it. The asymptote is the line that we appear to be approaching but don't ever quite reach. It's always horizontal for exponential functions. All right. And I'm going to go back to my calculator so we can actually see it. It appears to be when we're going to the negative side. So the further I go negative, right, I get all these. What does it appear that I'm approaching? It should be fairly obvious if you're using the table key on the calculator here. It's a 4. Okay. The one thing I want to point out to you is this. If we add something to the exponent or subtract something, you're going to find that that number is most likely going to be your asymptote. We'll talk about that in more detail later, but I want you to focus on that. So my asymptote is 4 for this graph, and I added 4. Okay. So how do I show that? Well, what kind of line is that? It's horizontal, right? So that's a y equals line. So I have an asymptote at y equals 4. Okay. That's also your relative min. All right, so now what was the next thing we were supposed to do? Plot the points, graph it, find the y-intercept. Well, we found our y-intercept. Our y-int was 0, 7. All right, and so now I need to go through and I want to do something called end behavior. I'm going to do that kind of over here where I have more room. End behavior. Okay, end behavior is written in a kind of weird way. As x approaches infinity, comma, f of x approaches what? So in other words, as my x's move further and further to the right, my y's approach what? They keep going up faster and faster and faster. So the further I go towards infinity on the x-axis, the more I go up to infinity on the y. So infinity, infinity, right? My x's go to infinity, so do my y's. They go up forever and ever. Now on the other side of things, as x approaches negative infinity, again, negative infinity on the x is back to the left. What is my y value approaching? And we saw this in the calculator. The further and further I go to the left, the more and more I am approaching what y value? And it should be 4, right? Remember, these y values seem to be approaching 4, but they never quite got there. So that is the asymptote that we are approaching. If there is an asymptote, either your left end behavior, which is the bottom one here, or your right end behavior, which is the top one of the two of them will approach that asymptote. Okay? So for an exponential, one of those will approach the asymptote every single time. All right, I'm going to stop this video there, and then I'll put the next couple of examples on the next video.